Question 11, it's got two parts to it. An interesting show that for part A, and then simply just doing the integration for part B. Starting with the first bit, we're trying to find out what R, the area, is. And we're trying to integrate. So we're integrating, well, we integrate Y with respect to X, don't we? And we're going from 0 here, a little bit of thinking about what's going to be this value here. And look, the X value, the highest that's ever going to be is 3. So I'm going to put 0 to 3 there. But because we want it parametrically, we want the integral of y dx by dt dt. So let's substitute these things here then. So we got the y is 2 tan t. And differentiating this, differentiating x here gives us, so cos goes to minus sine, and 2 3s are 6. So I've got minus 6 sine 2t dt. Let's go ahead and do this integration. So we've got, well, there's a minus 12 coming out there, isn't there? Minus 12 tan t. You know what? I'm not going to write tan t. I'm going to write sine t divided by cos t. And I also need to know the formula for sine 2t, which we should remember is 2 sine t cos t dt there. So the coses are cancelling. I've got sine times sine is sine squared. And then I've got minus 24 here. There's the integral we're trying to do. Now, at that point there, you could look at what you're aiming for and go, oh, look, I've got 3 marks. You could just go, I've made a mistake with the minus. Or you could do the A-level thinking and try and figure out what this is. But when x is 0, when x is 0, 0 equals 3 cos 2t. So that when x is 0, inverse cos of 0, pi over 2, divide by 2, pi over 4. So instead of putting a 0 here, I should have a pi over 4 there. And the other answer, when we do 2 pi minus this, that's when I've got the 0 here. Sorry, not when I do 2 pi minus that. The other answer is when 3 equals 3 cos 2t. That's when cos of 2t equals 1. And so that's when the cos is 0. So these bounds here are actually sort of, you might think, in reverse. And so at that point there, I've got the pi over 4 at the bottom. And so I can now switch them, put it around the other way, and then drop the minus. So look, I should think there's very few people are going to get that. Most people are just going to drop their minus out. But now I want most people to come back again and actually do this integral. So you should remember the formula for sine squared. So we're doing 24, the integral, and we're not doing a sine squared, we're doing a half of 1 minus cos 2t dt. You know, either of the trig squared, sine squared or cos squared is used by using this trig identity, isn't it? So we're doing 12, the integral of 1 minus cos 2t dt. A bit more room. So we've got t minus a half sine 2t, and that is going from 0 to pi over 4. So I've got 12 lots of pi over 4, take away, stick the pi over 4 in there, and what are we getting? We're getting half, aren't we? Putting the 0 in there, we got 0, 0. That's good. Grand total gives us 3 pi minus 6.